Hi, everybody. Here we are, April 28th, and this is our final organic chemistry lesson on polymerization and combustion reactions. You know, as I bring this unit to a close, I want you guys to be aware that if you take chemistry in college, 1 full year of chemistry in college will be inorganic chemistry, and that's what we've spent all of our year on except for this unit. When you go to college, though, organic chemistry is a full year course in addition to inorganic chemistry. So please be aware, we have just barely scratched the surface of this wonderful topic. Let's bring to conclusion these final 2 reactions. Polymers, polymerization. Polymers are very large compounds with high molecular weight, and they are made up of many repeating smaller units called monomers. So polymers, many, monomers, a single unit. It's a smaller unit. They link up by bonding to make these really huge compounds. There are so many examples of polymers: plastics, synthetic fibers. Most of our clothes now, unless you're wearing pure cotton, your clothes are made up of polymers. Proteins in our bodies, starches, cellulose, all of these are polymers. They are large compounds. Okay, so we're going to look at first 2 types of polymerization reactions. Okay, the first one is an addition reaction, and this just involves the linking or bonding of monomers together. Now, you will note I've got just 3 here. And looking at those, this is ethene. If you recall, 2 carbons, it's a double bond here with 4 hydrogens. This is ethene, an alkene. If I were to take ethene and combine many of them, thousands of ethenes together, I would make, through polymerization reaction, polyethylene. So it's impossible and unreasonable to expect you to write the chemical formula for a polymer, because polyethylene literally is made up of 2,000 of these. So the way you're going to see it represented is with some kind of brackets, or in this case, parentheses, and the letter N. You might have a letter X there, but these letters refer to some large number. So we could have 2,000 ethenes linking up, bonding up to produce a polyethylene. And so representing that polyethylene, there's X number of this representation. And just a quick comment here is you'll notice we have the double bond here and we're down to a single bond. Remember, ethene and other alkenes are unsaturated. They do not have the maximum number of hydrogens that could be bonded here. So there's room to add other and link up other compounds. In this case, ethene, over and over and over again. So it's an addition reaction. And in the addition of 2 or more ethenes together, you create a single bond in that carbon. And this bond here is going to be to another carbon. It's going to be a huge carbon backbone. So I have a notation here that plastics with the numbers 1, 2, and 4 are different varieties of polyethylenes. So I did a quick look in my kitchen today around here. So You must know this is my favorite spice. This is a number 1 polyethylene. And then food containers, the top anyhow, in this case is a polyethylene. Plastic number 1 examples. Okay, let's see what else we have here. So there are so many other plastics. I will never do it justice, but here's a few more examples. Polystyrenes. Again, these are polymers. And I have one example of a polystyrene. I actually had a little trouble finding this in my house, but you'll see your little number 6 here. And this happens to be a hot cup top. But there's a whole wide range of plastics that would have the number 6 polystyrene as the component. Then we have polypropylenes. I have 2 number 5s. I'm going to let you know another favorite. This is a favorite snack of mine at night. And this cup happens to be a polypropylene product. And then you have like your other food containers like this. That's a polypropylene as well. Then we have some polyvinyl chlorides. These are the number 3s. And these are so varied. I mean, cling wrap is really cool. I mean, it's this sheet-like plastic. That's polyvinyl chloride. But you can have some really strong plastic food trays and things like that made of polyvinyl chloride as well. So plastics are very diverse. They are all synthetic. They are a major global problem. We've got so much plastic around us, and they really do not degrade. So it's an interesting problem that needs to be solved globally. And I wanted to conclude in this part of the lesson with the number 7 plastics that you would see in the labeling of them. These are just categorized as other, and they have a whole range of examples. I just gave 2 pretty common ones. So nylon and fiberglass. Okay, so let's go to the second type of polymerization reaction, and this is called a condensation reaction or dehydration synthesis reaction. In these, again, we have monomers. This monomer is glucose, okay? And we have n number of glucose molecules that will be linking up and bonding together to make a huge starch. And when these glucose molecules, monomers, make the polymer starch, they link up however many, hundreds, thousands of them to make the starch. Every time there's a link made between 2 molecules here, 1 molecule of water is removed. So if you look carefully, we had 12 hydrogens and 6 oxygens here. When I link this up with another glucose molecule, I go down to 10 and 5. So 2 hydrogens are removed, 1 oxygen is removed for every link between 2 molecules of glucose. And because that water is removed, it's called dehydration synthesis or condensation reaction. There are so many examples of condensation reaction products. Any silicone products are examples. Nylons would be examples. Proteins, and proteins are so diverse. Hair, wool, enzymes, all of these things are examples of protein. Okay, and to conclude, this is just a small add-on to this lesson. I'm going to remind you of combustion reactions. We've actually learned about these way in the beginning of this school year when you were trained how to use the Bunsen burner. because usually it's either methane or propane that is burned. Could be butane too, but these alkanes can be burned in the presence of oxygen to produce carbon dioxide and water and lots of heat. And that concludes our lessons on organic chemistry. Bye.